Spreadsheets are useful for many problems, but they contain only a 2D grid of values and are limited by the screen size. We see two problems with spreadsheets. Code reuse is limited to copy and paste, and spreadsheets can only return scalar values. This user is creating a database of people, but all the spreadsheet recognizes is a grid of scalars. The user can write equations that return scalar results like the average grade for students, but can't retrieve complex results like the list of students who have taken CS 100. This user is writing matrix multiplications, but cells can only hold scalars, so the matrices are spread across regions. If these were 1,000 by 1,000 matrices, selection would be very difficult. It would be more useful if each matrix were held in a single cell. We introduce iSheets, an enhanced spreadsheet program which allows complex valued results and equation reuse. Cells can contain a scalar or a table. Complex values can be any size, as large as the database or a 1,000 by 1,000 matrix. In traditional spreadsheets like this grade sheet, everything is in the same grid, so resizing the column for one region affects other regions as well. This can be confusing for users. If instead we combine the data into separate complex values, then the regions can be edited independently. The list of students, for example, could be added to make as long as needed. We can also resize the columns for one region without affecting the other region at all. Referencing inside of complex values can be confusing. In iSheets, we can assign names to rows and columns to help with referencing. To find the total salary from January to March, the user can select the region in a sum equation. Named references make it more clear what equations are pointing to. They also make references more robust to insertions and deletions, since the names don't change. Sometimes users don't want to see all data at once. This user wants to see from May on, so they hide the rest of the columns. To bring them back, they simply click on the column to make them reappear. Complex values can be very large, such as this database, or small, such as these results computed from the database. This top cell is too big to be interacted with in place. The user can tear off the cell into a separate window and resize that window as large as is needed. That way the user can understand the data that they are looking at. In this matrix example, the cells are too big to all fit on the screen at once. It would be inconvenient to tear off so many cells. Instead, we use active and inactive sizes. Every row and column has an active and an inactive size. If we resize the row that contains the active cell, it updates the active size. Otherwise, it updates the inactive size. Now that these cells have active and inactive sizes, they can all fit on one screen with only the active cell large enough to see its details. Spreadsheets let users display visualizations of their data, such as a line graph. However, the graph and the data are in separate places, so both take up screen space. In iSheets, cells are assigned an active and an inactive format. When the cell gains focus, it displays its active format, like this table, until it loses focus when it returns to the inactive format, like this line graph. This saves screen space. Users often interact with their data in multiple contexts. Here we have a user editing their finance sheet on a very large screen. The screen is large enough to display their totals, their transactions, and their budgets all in one place. When the user switches to a smaller screen, they can also switch formats. This tab format displays the same information in a tabbed view that lets the user more effectively edit the information on a smaller display. Having multiple views of the same data makes spreadsheets useful no matter the setting. Complex cells contain large amounts of data, but standard spreadsheet functions can only return scalar results like average or sum. In iSheets, we can also have complex function results. We have written a set of functions, for example, that return database-like actions such as select and project. This lets us, for example, select the list of students from the database who have taken CS 100. These kind of complex results would not have been possible before, but open up many new options for spreadsheet programs. Another problem with spreadsheets is their use of copy and paste. This user wants to compare mortgage payments, so he copies his calculation to multiple regions. Then he notices there's an error in the original equation. He corrects the equation, but the change isn't propagated, so he has to copy the change and paste it once again. If later he wants to add another calculation, he must do the same thing, copying the data to multiple areas. Copy and paste keeps no connection between related regions of data. With complex cells, we can reuse blocks of equations from multiple cells. The user creates new complex cells which are linked to another cell's equations. Any change to the original set of equations will be propagated to all linked cells as well. That way the data for separate regions are linked to the same set of equations. We can even add more data to the bottom of the cell, and all linked cells will be updated as well. We have shown an enhanced spreadsheet program that allows complex valued results. We included named rows and columns, active and inactive sizes, multiple visual formats for the same data, and complex function results. We have also shown how complex valued cells allow for equation code reuse. These enhancements make it easier to express complex problems.